Hello friends, in my this video I am going to discuss about covariance. So before moving to the mathematical definition and intuition of covariance, just have a quick recap of variance. What is variance? Variance is nothing but average of squared distance from the mean, and it gives us the idea how far our dataset is spread out. Okay, if variance is more, that means the spreading of our dataset is more. If variance is less, that means spreading of our dataset is less. Here I have plotted two datasets. Okay, and suppose for both the dataset the average is mu, and with respect to mu, what is the distance of the data points in the one dimensional dataset we have calculated and we have plotted. So we can see that for the A dataset, for the A graph, at very lesser number of points are placed far away from mu or mean, and most of the points are placed closer to mu, so that we can say the spreading for the dataset of A is less, that means variance is less. Okay, and for the B dataset, if you consider, huge amount of dataset are basically far away from the mean of or mu. So as a result, we can say B is having very high variance, that this B's dataset is high much spread out. Okay. For one dimensional dataset, it is quite simple to visualize the shape of data. That is how the data is distributed. Like here we are concluding that for the first curve A, the datasets are congested, and for the second curve B, as more number of data points are spread out away from mu also, so we are concluding that variance is more. This particular conclusion can be easily done in one dimensional dataset, but if our dimension increases, then it is bit difficult to visualize this kind of thing in geometry. Okay, so for that we require covariance. That's what I have written here. For one dimensional dataset, we can visualize the shape of the data, but if the dimension is more than one, variance is not enough to visualize the data. So for that, what we will do, we will go to covariance. Covariance is basically it gives us the idea that whether x and y move in same direction or x and y move in opposite direction. That means if with increase in x, y also increases, or with increase in x, y decreases. That means whether reverse relationship is followed or whether same directional movement is followed. Okay, after my discussion you will come to know that in case of covariance, if it is positive, that means x and y moving in same direction. That means with increase in x, y also increases, with decrease in x, y also decreases. And if covariance is negative, that indicates with increase in x, y decreases, or with a decrease in x, y increases. That means x and y move in opposite direction when covariance is negative. But how and why, how we can predict this? That's what our main problem for the time being. Let us discuss that. So obviously x and y, how they are moving, to come to conclude that, we require some reference point. For that, what we will do, we will calculate the mean of x and y. And suppose mean of all the data points of our data set, if you take all the x coordinate mean, you will get x bar or mx. And if you take all the y coordinate mean of our data set, you get my. You just plot two lines and they intersect at this particular point, which is corresponding to x bar or y bar, x bar and y bar. Okay, now very simply you can conclude. See, these particular two lines after intersection, they have divided our plane into majorly four parts. Now see, here you can easily conclude that, for suppose consider the points which are situated here. Here what is happening? This particular part, in this particular part, whatever points are present, we can say for them x coordinate is lesser than the mean, but y coordinate is more than the mean. See, you can clearly understand x coordinate whatever points present here is less than x bar, but y coordinates are more than y bar. That means y is more than mean, but x is less than mean of x. So that means here in this particular part, the x and y are moving in opposite direction. That's what I have written here. In this particular part, they move in opposite direction. If you consider this particular part, see, for all the points placed here, having x coordinate more than x bar, similarly having y coordinate more than y bar. So kind of same directional movement, x also more than the mean of x, y also more than the mean of all the data points of the data points y coordinate. So the same kind of movement. So here they move in same direction. That's what I have written here, move in same direction. If you consider this quadrant, this particular slot, see, here x coordinates are more than x bar because all the points are placed in the right side of mx, or the mean of all the data points of x, all the data points x coordinates. So here x is more than x bar, but see, all the y coordinates are below the my line. That means all the y coordinates are less than the mean of y coordinates of our data set. That means x and y are moving in opposite direction because x is more than average of x, but y is less than average of y. So that means they are moving in opposite direction. Similarly, if you consider for this particular slot of our 2D plane, see, here x coordinates are less than the mean of all the x coordinates, but y coordinates also are less than the mean of y coordinate. See, I hope you can clearly see. So here x also less than average of x, y also less than average of y. So that means kind of the trend of data set moving placed here is following same kind of directional movement. So we are saying this is moving in same direction. So from here, like this, if we observe, we can clearly tell, but we require some mathematical expression for computing that single value we will get, and based on certain condition we can conclude that whether whole data set is in the whole data set x and y are moving in same direction or opposite direction. How we can conclude that? See, very simple. What we will do, forget about our previous coordinate, that is original coordinate system xy. Consider this one as our new coordinate system where origin is basically x bar and y bar. Now we can clearly say this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. And now we can simply say any data points which are placed in the first quadrant or third quadrant will have the trend of moving x and y in same direction. And for the new coordinate system, whatever data points are placed in second quadrant or fourth quadrant, they are having the trend of moving of x and y coordinate in the opposite direction. Now the problem is simplified much. Now just we need to know whether the data points is placed in first quadrant and third quadrant or second quadrant and fourth quadrant. How you calculate? See, very simple. Just consider normal coordinate system in a 2D plane. If both x and y are positive, that means either that point is placed in first quadrant or third quadrant. Why? Because if a point is placed in first quadrant, that means both x and y coordinate will be positive. And if a point placed in third quadrant, that means both x and y coordinate are negative. That means multiplication of x and y will give us result as positive value. So, and similarly in the reverse way we can say any point is placed in second quadrant or fourth quadrant. How you can say? Very simple. Multiplication of x and y coordinates should be negative, right? So now what we have to do, we have to just determine that for these data points, the multiplication of x and y coordinates giving us what result. Based on that, simply we can conclude. Okay. If they are giving us positive result, that means they are either in the first quadrant or third quadrant, that means moving in same direction, or if they are in the second and fourth quadrant, that means they are moving in opposite direction. That in that case their multiplication result will be what? Multiplication result will be negative. Now see, the problem is another part. Our new coordinate system is shifted from 0 0 to x bar y bar, but we know the data points coordinate as data point coordinates with respect to our main coordinate system, that is which is having the origin at 0 0, but for our new coordinate system the origin is shifted to x bar y bar. So for all the data points which we know the location xy with respect to origin, now we have to determine the coordinates of those data point with respect to new origin x bar y bar. And here the mathematics concept whatever we have studied in class 11, that is shifting of origin, that will help us. See, very simple, recall the concepts. Suppose I have our original coordinate system xy where origin is placed at 0 0. I am shifting my coordinate system without rotating it to some point having origin at h comma k point, and I am having a p point which is having the coordinate xy with respect to original coordinate system. That means when origin is 0 0, our p point having x and y coordinate as xy. With respect to new coordinate system which is having x bar y bar as x axis and y axis, the position of p is x bar y bar. Okay, that means original coordinate system is having the coordinate point as xy, but new coordinate is having the coordinate points at x bar y bar. Now we have to determine the relationship between xy and x bar y bar. Very simple. Consider this particular new coordinate system. Obviously in the y direction the distance is y bar, in the x direction with respect to our new origin the distance is x bar. And if you consider our original coordinate system, that is having which is having origin at 0 0, see this particular p point is having coordinate as xy. Okay, so this total distance is x and this total distance is y with respect to our original coordinate system, and this is hk, that is our shifted coordinate system origin point. So this is h and this is our k, and this particular part we know as y bar, so this particular point will be also y bar, this particular point is x dash or x bar, here also x dash. Okay, so we can simply conclude that this is x which is equal to h plus x bar, this is y which is equal to k plus y bar. So we can say the relationship is x equal to x bar plus h, y equal to y bar plus k, where x and y are the coordinates with respect to our original coordinate system, x bar y bar is the coordinate with respect to our shifted coordinate system, hk is the point where we have shifted our origin. Okay, so from here what we can conclude, x bar x dash equal to x minus h, y dash equal to y minus k. So and here in our particular case our shifted origin is x bar y bar, so we can say x dash equal to x minus x bar, y dash equal to y minus y bar. So what we can say, previously the coordinates was xy for with respect to original coordinate system, but when we have shifted our origin to x bar y bar point, our new coordinate system of all the data points become x bar y bar, which is equal to x minus x bar, y minus y bar. Now very simple, what I told you, this is our new coordinate system, and in the new coordinate system you know for calculating anything is in first quadrant or third quadrant, what we do, multiply simply x and y coordinates. So we have to just simply multiply x dash and y dash, which is our new coordinate of with respect to our shifted coordinate system. Okay, so what we will do is simply multiply x dash and y dash, and if x dash and y dash after multiplication if we are getting that as positive, That means those are placed either in the first quadrant or in the third quadrant. That means they are moving in same direction. And after multiplication of x dash and y dash, if we are getting negative, that means those are placed either in second quadrant or fourth quadrant with respect to our new shifted coordinate system. That means those trend are in reverse direction, because we have seen second quadrant and fourth quadrant are moving in opposite direction, and third and first are moving in same direction. Now for individual data points we have multiplied and we have got the result. But for the overall, for the whole data set, what is the trend we need to calculate? That means for the whole two-dimensional data set, the whole data set is moving towards positive direction. That means x and y are following same directional movement or reverse directional movement. If we have to calculate for whole data set, simply we will take summation and then divide by total number of data points. That means we will take average of that. That's all. That's what is covariance is. So covariance equal to summation over x minus x bar into y minus y bar by n. This is nothing but x minus y bar, y minus y bar is what? That is nothing but x dash into y dash. We are calculating to determine what is the quadrant of that particular x dash y dash data point. And x dash y dash is our x and y coordinate with respect to our shifted coordinate system, where we have shifted our coordinate from 0 0 to x bar y bar. That's all. So we are calculating for whole system what is the trend of movement. So after calculating, if we get this particular CV as positive, that means there are more number of data points having x dash y dash as positive. That means more number of data points are placed in first or third quadrant. That means moving in same direction. That means if covariance is positive, that means x and y move in same direction. That means if x goes up, y also will go up. If x decreases, y also decreases. But suppose if this particular average value becomes negative, then in that case we can conclude more number of data points present in second quadrant or fourth quadrant. That means they are following reverse pattern. That means if x increases, y decreases. If x decreases, y increases. Okay. So this is what mathematical intuition and formula of covariance. I hope you have understood this. This is what geometrical idea we require as a prerequisite to understand covariance. I hope you just have a recall of our concept whatever we have studied in shifting of coordinate in class 11. This is quite simple derivation. Okay, so this is all for my this video. Thank you for watching.